So in our previous lesson, we talked about how to graph trigonometric functions given the equation. In the equation, we saw how that could sort of translate to a description of the function or a description of the transformations of the function. And here we're going to go backwards. You have the option of graphing these questions as well, and the first time I taught this lesson, I did graph at the same time. In the interest of saving some time, we're just going to focus on writing the equation today, but I encourage you to then develop a sketch based on the equation and based on some of the math that you do, just for additional practice with graphing trigonometric functions. Okay, so we're going to do 3 examples today that have some descriptions of functions, and then we're going to be able to determine the equation at the end. Let's look at our first example. Determine the equation of a cosine function that has been stretched vertically by 5, has a period of pi, a phase shift of pi by 6 to the right, and a vertical shift of 2 up. Okay. And if we go back, just to recap some of the letters that we were working with here, and I'm just going to write out the sign. Oh, and I missed the sign at the end of, oh, there's a sign right there. Yeah, perfect. So we have an A that's out front. K represents a horizontal stretch compression. D, horizontal shift. And H, vertical shift. Okay, the very first thing we're going to note is that we are working with a cosine function. So I should have a cos sort of in the middle of my equation there. Okay. And let's see what letters we can fill in. I'm literally just going to write them off to the side here. The very first one that I see is we have a stretched vertically by 5. We have a vertical stretch of 5, which means that A is going to be equal to 5. Okay. Easier ones to find. We have a phase shift of pi by 6 to the right. Phase shift is another way of saying horizontal. When we talk about trigonometric functions, you can use the word phase. And it's pi by 6 to the right, which means that our D value is going to be pi by 6. And that entire bracket is going to look like x minus pi by 6. Another one we have is a vertical shift of 2 up. That's our H value, positive 2. Recall that H also tells us where the midline is located. And the only sort of tricky one to figure out is the period. We know that it has a period of pi, so we need to figure out the K value that's going to get you there. If you can't do this in your head, no problem. We'll do the math really quickly. Recall that in order to find your period, you use the formula 2 pi over k. But here we know the period is pi. And we can just rearrange our equation here to get a k value of 2. Okay, and that makes sense, right? A period of pi means that it takes half the time to get to the end of the first cycle as compared to a normal cosine function. A normal cosine function takes 2 pi to get there. This only takes pi. We're working at double speed. Okay, our k value is going to be 2. So we can write our final equation here. F of x will be 5 cosine of 2x minus pi over 6, all plus 2. Good job. Let's look at our next example. Determine the equation of a sine function that has been flipped over the x-axis, has a maximum of -4, a vertical shift of 1, and a period of 4 pi. Okay, there's a lot of stuff going on here. I'm going to write to the left-hand side the letters that we need to find, the coefficients or the variables we need to find. Okay. The first piece of information that I spot as being really easy is our vertical shift of 1. That is our h value, which is 1. We can also do the period thing right now. We've got a period of 4 pi. 4 pi means that it is going, it's taking twice as long, or it's moving at half speed. So our k value is going to be 1 over 2. And to work that out, remember we do our period is 2 pi over k, a period of 4 pi, and we rearrange our equation. Pi's cancel out, 2 over 4 simplifies to 1 over 2. We're moving at half speed in order to get there, okay? We know that our function has been flipped over the x-axis. That means that there is a vertical flip happening here, which is in the a. So I'm going to leave my a value. I'm just going to write a little negative sign there until we're figuring it out. And the last sort of clue I've been given is that I have a maximum of -4. Okay, that is the highest up that my function goes. Or sorry, I guess the lowest in this case that it's going to go, given our midline is located at 1. So we need to go from 1 all the way down until -4. That distance is going to be 5. And if you sort of struggle to see that, recall that our maximum is located at our a value plus our midline. So maximum here is -4. Our a value is unknown, but our midline is 1. And I'm going to rearrange that to be -5 is equal to a. So our a value, we already knew the negative part because it had been flipped, and our a value is -5. We've been provided with no other additional clues in terms of a phase shift, so there's actually no d value. I'm going to just write a 0 there, but you know at the end of the day that we don't need to write anything. And the last thing that we forgot to highlight is the fact that it is a sine function. And so our final function here will be -5 sine 1 over 2x, all plus 1. All right, let's do our last example here, and this one's fun. We have to find both the cosine and the sine function equations. Let's start with doing our cosine first. No, let's do with our sine first. No problem, we'll do sine first. Okay, what we know is that the graph is starting at -1, -pi/3. So because we're working with the sine function, we know that that's starting directly on the midline and following a phase shift. So, and you know what? I think I got these values backwards, so let's fix that. And let's work instead using our, let's do this right, -pi/3, 1. There we go, that's what we'll do instead. Okay, so we need to find our a, our k, our d, and our h. And as I was saying, we know that when it starts, or for the sine function, it starts at the starting point. The starting point is on the midline, and so h is going to be -1. It comes directly from right in here. Just like our d value comes from the starting point as well. It's going to be -pi/3. And because that's a negative, when we write it in the bracket, it's actually going to look like x plus pi/3. Counteracting, we're shifting this to the left. It's starting in the negative sign. Okay, we've been provided that it's got an amplitude of 2. And we just need to figure out the k value. The k value here, we've got a period of pi/2. That's 4 times as fast, okay, as our usual period. We can calculate the period if we need. Our period was pi/2. Okay, we can do some rearranging. And continue to sort of flip things around. So I brought my second sort of denominator there up to the top. And so our k is equal to 4. Remember I said we're moving 4 times as fast. So our sine function here, we've got all of our points. That was really straightforward to do. Our sine function is going to be f of x is equal to 2 sine 4x plus pi over 3 all minus 1. Okay, our cosine function is going to look a little bit different given these clues. I'm going to write my a, my k, my d, and my h once again. We're being provided with an amplitude of 2. We already know that from right here. Our period is going to be the same. Cosine and sine have the same period, so I can grab a k value of 4 as well. Now we know that the graph here is starting at negative pi over 3, negative 1. And this is a cosine function. It's a positive cosine function. And so it is going to actually start at the maximum and go down to the minimum. That's what it's going to look like. Our horizontal shift is going to remain the same. It doesn't matter that we're starting at the max versus with sine where we're starting at the midline. Horizontal shift will be consistent. So my d value is going to be consistent here at negative pi by 3. I'm still going to be writing x plus pi by 3. Sorry, that's in the wrong color. The only real thing is going to be a vertical shift. So if my function is starting at negative 1, negative 1 is my maximum. Negative 1 is my max, and if I have a midline here, and this distance is 2, then all the way down to my minimum, not that this really makes a difference, would be down to negative 3. What I'm actually trying to figure out here is my vertical shift up. My vertical shift tells me what is the distance to the midline. Recall that in a cosine function or with all functions, the max is equal to the midline plus a. We know our max is negative 1. We need to know our midline or our h value. And we know our a is 2. I can rearrange here to solve for h, which is going to be negative 3. Okay, so if my maximum is at negative 1 and it takes 2 for me to get there, then the midline of my function is negative 3. So I'm going to drop a negative 3 for my h value. That's really going to be the only difference between the sine and my cosine functions is the h value, and it's simply because of the nature of the function and what it means when we say starting at. Okay, let's conclude here by writing our function out. F of x is equal to 2 cosine of 4 x plus pi over 3, and then this time I'll take away 3. Okay, so to recap, you just sort of look at the clues that you've been given in the equation. Remember that you're looking for 4 values, a, k, d, and h, and see if you can sort of piece them together, knowing what you know about transformations of trigonometric functions. Great work, everybody!